somewhere out past the edge of everything we can see with the naked eye. A machine built by human hands in 1977 is still awake. It has no crew, no hope of rescue, no way home. For 19 and a half hours, one way, a radio signal crawls from that machine back to Earth, fainter every single year than a whisper across a canyon. And soon, not today, not this year, but soon, that whisper is going to stop. This is the true story of Voyager 2, not a manufactured warning, not a fake transmission. The real countdown NASA itself is racing against, instrument by instrument, watt by watt, as humanity's farthest flung machine runs out of power in the dark. Here's what's actually happening, 300 billion mile pattern by pattern. Part 1. The machine that refused to die. Voyager 2, launched on August 20th, 1977. Just a few weeks before its twin, Voyager 1, and yet on a completely different path. A slower, longer road that would eventually make it the only spacecraft in human history to visit all 4 giant planets, Jupiter, Saturn, Uranus, and Neptune. Think about that for a second. One machine, 4 planets, a single grand tour that took advantage of a planetary alignment that only happens once every 176 years. If Voyager 2 had missed its 1977 launch window, that specific alignment, the one that let it slingshot from world to world using each planet's gravity as a slingshot, wouldn't come around again until the next century. It almost didn't make it past the first stop. In April of 1978, ground controllers went quiet for a stretch of time. No commands sent up to the spacecraft. Voyager I-2 interpreted the silence exactly the way it was programmed to. As a sign, its primary radio receiver had failed. So it did what it was built to do. It switched to its backup. That backup receiver worked. But it had a flaw. A failed capacitor that meant it could only lock onto a signal sent at one extremely precise frequency. And that precise frequency kept shifting because of the Doppler effect from Earth's rotation, and because the receiver's own temperature nudged it around too. For the rest of its multi-decade mission, through Jupiter, through Saturn, through Uranus, through Neptune, Voyager 2 has been listening to Earth through a radio receiver with a manufacturing defect from before some of its mission controllers were even born. Every single command NASA has ever sent it since 1978 has had to be precisely tuned around that flaw. It never fully broke. It adapted. And it kept going. Part 2. The Grand Tour. By the time it reached Jupiter in July of 1979, Voyager 2 was already rewriting textbooks. It caught the Great Red Spot mid-transformation, drifting, changing shape, changing color, in ways the earlier Pioneer probes had never detected between their 2 flybys. It returned over 17,000 new images. Together with its twin, it helped map more than 80% of the surfaces of 2 of Jupiter's giant moons, Ganymede and Callisto, at a resolution good enough to pick out features just a few miles across. Then it kept going. Saturn in 1981. Its instruments drank in the storms, the rings, the strange chemistry of a planet made mostly of gas. Then something no spacecraft before or since has done. In January of 1986, Voyager 2 became the only human-made object to ever fly past Uranus. It came within about 81,000 kilometers of the cloud tops, close enough to spot 11 previously unknown moons, all named for characters out of Shakespeare and Alexander Pope: Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Belinda, Puck, Perdita. It found Uranus's magnetic field wasn't just tilted, it was wildly misaligned with the planet's own spin axis, unlike anything seen at any other planet up to that point. It measured winds up to 450 miles an hour. It found evidence suggesting a scalding ocean of water buried some 500 kilometers beneath the cloud tops. 3 years later, in 1989, it did it again at Neptune. The only spacecraft ever to visit an ice giant twice, the only one to visit either ice giant at all. It photographed Neptune's largest moon, Triton, and its strange icy volcanism. And then, its planetary tour complete, Voyager 2 turned its cameras away from the planets it had spent 12 years chasing and pointed itself toward the stars. There would be no more worlds to visit. Just the dark, and whatever the dark had waiting. Part 3. Crossing the line. No one had crossed. Here's something people don't always realize. Leaving the solar system isn't a single moment. It's a series of thresholds, each one further and stranger than the last. On August 30th, 2007, Voyager 2 crossed something called the termination shock, the point where the solar wind, the constant stream of charged particles blasting out from the sun, abruptly slows down as it starts running into the thin gas of interstellar space. Past that point lies the heliosheath, a kind of turbulent, churning border zone. Voyager 2 spent over a decade crossing it. Then, on November 5th, 2018, Voyager 2 broke through entirely. It crossed the heliopause, the true edge of the sun's bubble of influence, at a distance of about 119, 7 astronomical units from the Sun. That's over 11 billion miles. It was moving at just over 15 kilometers per second, and for the first time, its instruments started sampling something genuinely new, the actual density and temperature of the plasma that fills the space between the stars. Voyager 1 had made that same crossing 6 years earlier in 2012. But Voyager 2 carried something its twin didn't, a still functioning plasma instrument, which meant it could do something Voyager 1 physically could not. It could directly measure the interstellar plasma itself rather than just infer it indirectly. For years, Voyager 2, Part 5, the 2 degrees that almost ended it all. Part 5, the 2 degrees that almost ended it all. If you want a real, the world held its breath moment in Voyager 2's story, not a manufactured one, an actual one, this is it. In the summer of 2023, a routine set of planned commands was sent up to Voyager 2. Somewhere in the execution, something went wrong. The spacecraft's antenna ended up pointed about 2 degrees away from Earth. Just 2 degrees. At a distance of over 12 billion miles, 2 degrees might as well have been 2 light years. Voyager 2 stopped receiving commands. It stopped transmitting data anyone could hear. Contact was severed. The spacecraft was still flying, still alive, still following its planned trajectory. But for weeks, humanity had no way to talk to it and no way to hear it talk back. Voyager 2 has a built-in safety behavior. Several times a year, its onboard software automatically resets its orientation to make sure its antenna repoints itself toward Earth. Mission planners knew the next scheduled reset wouldn't come until mid-October. That was the fallback. That was the wait. But NASA didn't just wait quietly. On August 1st, 2023, engineers using the Deep Space Network's massive dish in Canberra, Australia, managed to detect a faint carrier signal from Voyager 2. Proof it was still alive and still broadcasting, even if no one could read what it was saying. Then, in a maneuver engineers only half-jokingly called an interstellar shout, Canberra blasted an extraordinarily powerful signal across more than 3 billion miles of space, instructing Voyager 2 to reorient itself. The command would take over 18 hours just to arrive. Then there'd be another 19 hours before anyone on Earth would know if it worked. 37 hours, total, of not knowing whether a 50-year-old machine had just heard humanity calling its name across the dark, or whether it was gone for good. At 12:29 a.m. Eastern Time on August 4th, 2023, the data started coming back in. Voyager 2 had heard them. It reoriented. It was, in the words of the mission team, operating normally, still exactly on its expected trajectory. That's the actual transmission story worth telling, not a warning from beyond. A conversation, nearly lost, recovered by nothing but patience, physics, and one very well-aimed radio dish in the Australian outback. Part 6. What happens when the last instrument goes dark? So what does a final transmission from Voyager 2 actually look like when it eventually happens? It won't be a message. It won't be a warning. It will probably be silence where there used to be a signal, a scheduled contact window that simply doesn't produce the faint carrier wave the Deep Space Network has learned to expect, year after year, for nearly half a century. NASA's engineers have been honest about the uncertainty here. Even with the most careful power rationing imaginable, they've said outright that the Voyagers have been weathering deep space for close to 50 years now, and that unforeseen problems, old hardware failing in ways nobody can fully predict at those temperatures, at that age, at that distance, could shorten the runway at any time. The 2030s target is a hope, built on good engineering and a lot of hard-won experience. It is not a promise. When the last instrument does finally go quiet, whenever that turns out to be, Voyager 2 won't stop existing. It won't stop moving. It will simply keep drifting, exactly the way it has since 1977, at roughly 15 kilometers every single second, carrying its golden record of Earth sounds and images and greetings in dozens of languages, forever, into the space between the stars. No power, no voice, no way to phone home. Just a silent, drifting monument heading in the general direction of the constellation Telescopium for the next several tens of thousands of years until, if ever, it happens to pass near another star system at all. That's not science fiction. That's the actual, calculated, real trajectory of a real machine, doing exactly what it was built to do until the very last watt runs out. Part 7. Why this matters more than a manufactured scare. It's worth asking, why do fake Voyager warned us videos keep going viral? Probably because the truth, stripped of the theatrics, feels almost too quiet to trend. There's no monster, no message, no secret. Just entropy. Plutonium decaying watt by watt, year by year. Exactly the way physics said it would 50 years ago. But maybe that's exactly why the real story deserves to be told with the same weight as the fake one. Voyager 2 is right now the furthest reaching act of exploration our species has ever attempted. It has been flying for longer than most of the people reading or hearing this have been alive. It has survived a broken primary radio receiver, a Doppler-shifted backup, a 2-degree pointing error that nearly ended everything, and 49 years of cosmic radiation eating away at its circuitry. And it is still, as of this recording, transmitting real data from a region of space that no other human instrument has ever sampled. Every watt NASA squeezes out of a shrinking, decaying power source is a deliberate choice to keep listening a little longer. Every instrument they reluctantly switch off is a trade they didn't want to make, accepted only because the alternative was losing everything right now instead of losing one thing later. There is no warning buried in Voyager 2's signal. There's something better and stranger, proof that something we built out of aluminum and gold-plated copper and 8-track era computer chips can keep working, keep discovering, keep reaching back across 19 and a half hours of empty space to tell us it's still there for far longer than anyone who built it ever expected. And someday, not with a warning, not with a message, just with silence where a whisper used to be, it will stop. Until then, it's still out there, still listening, still transmitting.